That was amazing. What an amazing story. Thank you very much. I have the privilege of teaching and doing research at the University of Manchester, and they both bring me such different thrills and challenges. And I love the fact that I can do both and have sort of a management role as the Vice Dean and things as well. But I'd like just to touch on a couple of projects that I work on in my research. There are 14 World Engineering Grand Challenges in the world, and I'm very privileged to work on one of them. I engineer the tools of scientific discovery, and I use radio waves to do this. And it really sort of taps in for me the scientist and the engineer in me. So I'm always asking why, which lots of people do. That's the scientist in me, and then I've sort of evolved. Sorry for the scientists in the room, but I've evolved and become an engineer, and I ask how as well. So engineering the tools of scientific discovery is like the perfect job for me, and so I help astronomers understand what's going on in the universe. Like I say, using radio waves, I design instrumentation for ground-based and space-based radio telescopes. So the radio telescopes are sort of, if you've been to Jodrell Bank, hopefully lots of people have been there. I used to work out there. I still do a lot of my research with them. So they're sort of the big dishes that look like sort of big satellite dishes, and they are the telescopes, the radio telescopes. And I'd just like to chat about two projects that I'm currently working on. One of them is called ALMA, the Atacama Large Millimeter Array. So this is an array of 66 dishes out on the Atacama Desert in Chile, 5,000 meters above sea level. And it's such an amazing project to work on. Yes, it's generating amazing science for the scientists, but as an engineer, there are so many amazing things to work on with it. It's even just being 5,000 meters above sea level being able to fit it out up there is an amazing achievement. It has a supercomputer up there that is the highest supercomputer in the world. It is generating 17 million operations every single second in order to produce the data and produce these amazing images that the astronomers are doing, and that's the equivalent of billions of pounds worth of personal computers in order to make the necessary calculations as well. The images have 10 times more resolution than the Hubble Space Telescope, and this is a ground-based instrument. I mean, it's an incredible instrument to work on. The dishes themselves, they're several meters in diameter. The dishes themselves cannot deviate from a perfect dish, from a perfect parabola, by more than 20 millionths of a meter. Every single one of them does not deviate from more than a perfect parabola. And that's quite difficult to do when the temperature between day and night can be as much as 40 degrees Celsius. This is huge. So it's an amazing project to work on. And I'd just like to share a recent discovery that the astronomers made using this instrument that I've been very lucky to work on. They were observing a celestial source, a star. It's called a young massive star, and it's 1,500 light years away. And they were observing it with ALMA, and they saw sodium chloride was being emitted from this star. Table salt was being emitted from this star. And I was like, that is amazing. What does it mean? And the astronomer's like, I don't know yet. I have no idea. But it's such a great project to work on for the next generation as well, because we don't know what it means. What does it mean that table salt is glowing in our galaxy? We just don't know. But somebody needs to know, because maybe it's really, really important. And so that next generation need to be working on this as well. And of course, where is the UK base for ALMA? Well, it's at the University of Manchester, and that's why I work on it. The second project I work on is the Square Kilometre Array, and I think several people may already know about this. It's the Square Kilometre Array is the SKA, and of course the international headquarters are at the University of Manchester. This is another £1 billion project. It's currently being built, but it will be hundreds of thousands of antennas, so dishes, as well as sort of the aerials, the dipoles that you get on top of houses and things. Hundreds of thousands of those, all connected, but across an area in Western Australia and then a remote area in South Africa. Now, the sheer size of this will be 1 square kilometre's worth of collecting area. So imagine a telescope, that was 1 square kilometre's worth of collecting area. Imagine what you can observe in the universe with this. And it will be 50 times more sensitive than any other instrument in the world ever. It's such a big project to work on. I think my favourite fact about this is that it will be so sensitive, it will be able to detect an airport radar-like signal on a planet 10 light years away. So sensitive. And the amount of data this thing will generate is enormous. It's estimated that these dishes alone will generate more than 10 times the global internet traffic. 10 times the global internet traffic. So if you could take the SKA data in one day and download it as a song and play that song would last for 2 million years. It's a very good song. But if it was built now, so we're just building it, it's 10% being built now in Western Australia and South Africa. If the full SKA was built right now, we would have to throw away 90% of the data. 90% of the data. It would be tragic. It would be absolutely tragic, because you'd lose those sort of serendipitous science moments where you think the really good stuff's over here and the data over here, but actually the wow moment is over here in the data. You'd be throwing all of this data away. So if it was built right now, we'd have to throw 90% of the data away. We need quantum computing. We need the next generation to be thinking about how are we going to solve this problem, because we cannot keep all of this raw data from this one experiment, from this one telescope in the world. And so it's so important that we have that next generation being inspired to work on just the projects that even I'm just working on as well. We've managed to look at some sort of technology transfer out of the world of astronomy, which was always my passion, and I love it. But I wanted to see if I could sort of take the technology that we've done within astronomy and see if we can move it to some of the other grand challenges that the world faces as well. So we've moved some of the technology into farming. And I have these amazing conversations where in the morning I'm talking to NASA, and in the afternoon I'm talking to a farmer in Worcester. And you're talking about more or less the same thing. It's such a lovely environment to work in. And you might think the technological challenges are quite different, but actually, trying to observe something that is millions of light years away and communicate with that is a farmer trying to communicate wirelessly in the soil. So if you're trying to put some nodes in a soil and trying to understand what's happening in the soil, to try and see if you need to water it, so saving the precious resource we have, seeing if you need to add nutrients, etc. And maybe that's only 2 or 3 meters in the soil. The communication challenges between millions of light years and several meters in the soil are actually quite similar. And so we've been able to technology transfer into farming as well. We've also been able to do it with building and helping people who are visually impaired. So if you imagine if you were visually impaired, several buildings, public buildings, are all equipped with Braille signs. But actually, if you're a visually impaired person, knowing where those Braille signs are is quite a challenge. So we've been working with radio frequency identification tags, so RFID tags, the type of things that you see on clothing and your shopping and things like that. And what we're doing is embedding them in buildings. So you might take sort of a museum or a cafe or something like that, and you're embedding a tag inside all of these Braille signs. And so what happens is a visually impaired person can come into a building and have a mobile phone that is talking to them, and as soon as they enter the building, all of that information can be downloaded onto their mobile phones. So all of the information from these tags, because they've all got a unique identifier, is downloaded onto their phone, and then it can say, okay, in 10 meters you have 3 steps up, and then you're into the building. The ladies' toilets will be 20 meters to your left-hand side now, etc. And so we're helping people to navigate around buildings independently, which is such an important thing for someone who's visually impaired. And this is using the same technology that I've used on ALMA and on the square kilometre array as well. And they're such lovely projects to work on, and I get questioned quite a lot, because a lot of my research is in designing things that will help us look deeper into space. Lots of people say to me, well, look, we've got lots of problems on this earth. Why are you spending millions of pounds looking, elsewhere? And there is a social responsibility angle to it. Manchester, as you know, by the way, I think we should always be curious, and that's why I do it. Curiosity and never not to be curious is a good thing. But Manchester, as you know, we have a social responsibility agenda that is just as important as our teaching and learning and our research agenda. To me, it sets out why we do our teaching and why we do our research, and it's really, really important to me. And so I feel very lucky that I have some time to go out and talk to the next generation about my work, about other people's work, and hopefully inspire them to come, hopefully to Manchester, but to study science and engineering. And I remember saying it to a daughter of a friend of mine, and I'm saying, I think it's really important that we do it, as scientists, as engineers, that we come out and talk about our work. And she was like, yeah, me too. And I was like, why? Why do you think it's important? Because I think it's important, but why do you, as a child at school, why do you think it's important? And she had a bit of a think, and I videoed her saying this. I've used it in several talks, and she sort of had a bit of a think, and she was like, well, I'm you in the future. So if you help me now, in the future, I can be better than you. And you're like, well, what better motivator for anyone? What better motivator for anyone else in this room? It certainly motivates me to do my research and my teaching. But I think it should motivate everybody to help people, students of the University of Manchester, become better than we are now. Thank you very much.